This kitchen is a laboratory for testing the boundaries of matter. Every time we cook or clean, we are managing the way substances behave. Take a glass of ice melting on the counter. The solid cubes are turning into a puddle, but every drop in that glass remains water. If you put that liquid back into the freezer, you get the exact same ice cubes you started with. Now look at the frying pan. Crack a raw egg into the heat and watch the clear, liquid white turn solid, opaque, and bright white. Try putting that cooked egg back in the fridge. There is no way to unfry it. The raw egg no longer exists. This is our first distinction. When a material changes its shape, its size, or its state, like the ice, but stays the same substance, we call it a transformación física. But when the original material is destroyed to create a new substance with entirely different properties, like the egg, it is a transformación química. Since we cannot watch atoms rearranging themselves, we look for macroscopic signs that matter has crossed the chemical boundary. One sign is mudanza de color, a change in color. When an iron gate develops reddish-brown spots, you are looking at rust, a new substance born from the iron reacting with air and moisture. Another sign is gas subindo, or gas appearing where there wasn't any. The bubbles that make a cake rise in the oven are carbon dioxide being generated directly from the wet ingredients. Your nose is also a sensitive detector for a cheiro novo. It knows instantly when milk sours or a piece of fruit rots because it's detecting substances that weren't there before. Finally, look for luz y calor saindo. A burning candle flame is a chemical reaction that releases the energy stored inside the wax as light and heat. When you observe these dramatic sensory shifts, they provide the evidence that the material has transformed into something new. You can watch both types of transformations happen to a single ingredient on the same stove. In Act 1, you put raw sugar in a pan and melt it into a clear, golden syrup. If you take that pan off the burner and let it cool, the syrup hardens back into sweet sugar. It changed state, but it is still sugar, a physical transformation. In Act 2, you leave the heat on. The golden syrup suddenly turns pitch black, releases smoke, and begins to smell bitter. You can cool that black mass down as much as you want, but it will never be sugar again. The heat has forced the original molecules to decompose into entirely new substances. Heat doesn't automatically mean chemistry. The only test that matters is whether the original substance survived the process or was replaced by something else. You might have heard that physical changes can be reversed, while chemical changes cannot. In a lab, that rule often breaks down. With enough energy and specialized equipment, chemists can sometimes run a reaction backward, like extracting pure iron from a pile of rust. When we call a chemical change irreversible, we really mean it's impossible to undo in a normal kitchen or on a job site. Instead of relying on reversibility, stick to the more reliable question: did a new substance form? This distinction between state and substance created a paradox that confused scientists for centuries. They set up a clever experiment by placing a lit candle on a highly sensitive scale and watching it burn. As the chemical reaction of the flame consumed the wax, the scale tipped, the mass decreased. This presented a mystery. Where was the wax going? Was the matter being destroyed, or was it simply becoming invisible to the eye? Solving this required a scientist to account for every invisible gas produced by the flame. By measuring those hidden products, he proved that in nature, nothing is ever lost, a discovery we will explore in our next lesson.